It's pretty fantastic to be in front of the Ballpex organization again and talking and sharing with you. Giselle and I were just talking before this call. It's been about a year and since I've talked to the organization, and we are a proud partner with Sigma Stretch Film. And I think what we want to do today is build on some of the information that we shared last time with you. And then, like Giselle just mentioned, we're going to focus very heavily on solutions that are out there for plastics, whether it be plastic film or other plastics that are out there. So the title of our presentation is, Sustainable Plastic Solutions. And, again, brought to you in partnership with Sigma Stretch Film. Let's kick this thing off. There we go. So I think everybody knows, whether you're a consumer or in the industry, that plastic waste has really become a pandemic. And when I say pandemic, we see plastic waste everywhere, whether it's on the shores, the beaches. We see legislation coming down. Canada's implemented quite a few legislation pieces that are far reaching, and actually other governments, including the US, are looking at what Canada is doing, and they've been very progressive. But really what's driving the plastic waste industry or solutions to plastic waste is you, the consumer. And you, the consumer, are pushing on brands, whether it's the restaurant chains, the grocery chains, the major manufacturers like the Coca-Colas, the Clorox, or PepsiCo. You're pushing for options that are more environmentally friendly when it comes to plastics. And of course, that pushes on the plastic producers. And those plastic producers, whether it be the Exxon Mobils, the Braskins, the Lyondels, the Chevrons, are really driving new technologies, new investment, and developing solutions that are available. And they're available now. And I think many in our, in our countries or here in North America don't realize there's solutions out there. So I'm going to talk a little bit about that today. But I think before I do that, I think it's super important to understand how traditional plastic is made. Traditional plastic is made in a very linear model. And you're probably questioning, what is a linear model? Well, a linear model is we take oil from the ground, we produce a plastic resin, and we mold it, we inject it, we make some kind of plastic product, whether it be stretch film, whether it be a plastic bottles, whether it be a car bumper. Well, when we're done using that particular product, you as the consumer, very often, it's thrown away. And if you look globally in the world today, about 91% of the plastics that are made today are not recycled. So therefore, this linear model means we're taking from the earth, we're using it, we converted it into this plastic product, and we buried it back into a landfill again. So it's a very linear model, and ultimately, it's not sustainable. You may have heard of this circularity term. And when I say circularity, it's really a new model that is trying to eat away at this linear model that we've had. And when I say eat away at it, it's trying to figure out how to use less virgin resources. This graphic actually depicts, what this circular model looks like. I think all of us are pretty familiar with mechanical recycling processes. So when you think about PET bottles that might be, collected, whether it's your home or at your business or, out in the local city, those products today, you consume them. We as recyclers collect them, we sort them, and we go through this, what we call a mechanical recycling method. And the mechanical recycling method is, in layman's terms, more of we take the plastic, we clean it, we sort it, we melt it, we make something else out of it. And that something else could be, make it into a car bumper. It could be, making it into a pallet, composite decking, but we've made something else out of it through mechanical recycling methods. I think everyone is, pretty familiar with that type of process. The process that you're not familiar with is what these new advanced recycling technologies that have developed here in North America. And when I say advanced recycling, it's technologies that are actually at the molecular level, figuring out how to break plastics down or filter them at a molecular level to make new resins again. And when I say new resins, these resins are indistinguishable from the resin that's manufactured today from petroleum. So therefore, it's a very advanced process. And if you look through either advanced recycling or mechanical recycling, we've now figured out, okay, we can reuse these products in an endless, infinite loop and develop this circular model where no longer we're having to pull petroleum out of the ground and make new plastic products. We can actually make plastic from plastic. I mentioned this already, but just to be clear, because I think it's always good to see it. This is something that we do today in partnership with Sigma Stretch Film. Our partnership allows us to go into customers that are using stretch film, and at some point they've decided that they need to discard that stretch film. Well, today we collect stretch film from Sigma Stretch Film customers. We bale it up, and if you can see in that one picture, that baled material is taken to one of our processing facilities where we sort it, we clean it, we process it, we more or less melt it down, and we make these new plastic pellets. Well, what happens to these plastic pellets? This is a perfect example. Sigma Stretch Film offers a product where they actually use our recovered resin, and that's very often called a post-consumer resin, so a PCR material. Today, that product actually has 25% and can be up to 50% of PCR content. That means 25 to 50% of the film inside that film is being reused again. And this is a mechanical recycled process that's available to you today. We're doing this with a lot of different plastics, whether it be, water bottles turning into fiber, whether it's, scrap laundry detergent bottles being made into pallets or car bumpers, whichever, but that is a very mechanical process. Let's talk about the difference between a mechanical recycling process and what is an advanced recycling process. I kind of mentioned some of the, a little bit about that, but, more specifically, most of these are fairly scientific. They've typically high technology involved. One of the predominant technologies out there is this process of pyrolysis. And pyrolysis is more or less where we take polyethylene or polypropylene, we put it in a chamber without oxygen, and we more or less melt the plastic down back to an oil. We filter that oil, just like in this beaker that you can see on the screen, and we're able to send this back to the refinery and crack it again and make new polyethylene. Some of the other processes are out there: methanolysis for recovering PET, gasification, molecular filtration. Today we are actually taking polypropylene super sacks from Clean Farms in Canada, and we're collecting those polypropylene sacks, and we're doing a molecular filtration on those days to recover those processes. So your own local government has figured out a way to kind of harness this new technology and give new life to plastics. Oops, excuse me. Let's talk more, just so you can see it in picture, a little bit more of a picture form. On the left, you see these used plastics, and they go through a pyrolysis, which is that heat step I talked about. But if you notice, we're actually breaking the polymer chains, and this is super important to understand, because it's what we've essentially done is we've taken the compound, we've broken the bonds. That way we can reform it. So the difference with this process is that we're actually making oil from this process so we can make brand new resin again. And this recycled virgin resin is no different than resin that's made from raw petroleum that's pulled out of the ground. So it's infinitely recyclable and can be done over and over and over again. I think it's important to understand what the process looks like. You know, advanced recycling really is a complementary process to mechanical recycling. So today, plastic wastes that are in your facility, a lot of the same steps have to happen. And when I say the same steps, I'm talking about we still have to collect it. We still have to sort it. You know, mechanical recycling, because we're melting it and making something else, you know, it's got to be highly sorted. It's got to be very clean in order for us to produce something else out of it. These advanced recycling processes are much more tolerant of mixed waste streams. You know, when we take something through a pyrolysis reaction and we melt it down, materials that don't melt are, you know, just become char and they just are contaminant. So more or less, it doesn't affect the product. It's just a yield issue. So because of that, advanced recycling processes are way more tolerant of potential contamination, which is helpful to your organizations and, you know, the manufacturing and distribution centers out there, because now we may be able to recycle some plastics that we were not able to do today. You know, the final step of washing, grinding, pelletizing, well, that mainly happens with mechanical recycling and chemical recycling. You know, it's infinitely recyclable because we can do it over and over again because we're making new resin. We're not just taking material, reheating it, and forming into a new part. You know, and again, these new products, you know, mechanical is more circular. Very often, though, it's what I call downcycled. And when I say downcycled, I'm talking about maybe we're taking stretch film and maybe we can't recover it for some reason. Maybe it's, you know, a certain color or a heavy contaminant. Maybe it has to be downcycled to making plastic lumber. Well, plastic lumber is a new product. It's not part of that circular model, and therefore it may be downcycled, where in chemical recycling, we've actually created it back into virgin. And when we've created it back into virgin, we can go into some really high value applications. So where you can take those materials, could be in a medical environment, it could be an FDA environment. So the advantages of both these processes, both mechanical and chemical, really opens the door to potential solutions for plastic waste out there today and, you know, in our countries. The biggest challenge, though, both with mechanical and advanced recycling, is feedstock. And when I say feedstock, I'm talking about we actually, believe it or not, have a hard time collecting materials, getting manufacturing and distribution facilities to understand what they can and can't do with their plastic waste. Or perhaps there's limited access when you go into remote areas in Canada. There may not necessarily be recycling facilities close by where materials could be aggregated and baled. And, you know, really across, you know, Canada as well as in the US, there's a lot of lack of standards. People have a real misconception on what can be recycled and what can't be recycled. So there's just so many different rules, a lot of fragmentation across current programs here in North America. And, you know, there's some pretty interesting statistics out there that, you know, most individuals believe that if they throw something in the recycle bin, it's actually not recycled because some of the bad press that's happened with, you know, certain recyclers out there where they actually haven't recycled your product. So there's a lot of doubt. And because there's a lot of doubt, there's a lot of confusion associated with what can be recycled and what can't be recycled. And because of that confusion, I think all of us at some point kind of throw up our hands and, and it becomes kind of analysis paralysis, and where we don't actually focus on figuring out how to develop a solution for, you know, our plastic waste. There's a lot of lack of sorting capacity, which is quickly changing here in North America. You're seeing more and more investment you know, especially from the petroleum companies on figuring out how to collect, aggregate materials. Our company moves a little over 190 million pounds a year of plastic waste, and we're looking for more. That's part of the relationship that we have with Sigma Stretch is, you know, going into their customers and helping them get plastic waste out of their facilities. Because at the end of the day, you know, we can't produce some of these products with a 25 or 30% recycled content unless we actually have feedstock. So we actually need help. And that help is, you know, through expanded collaborations, whether that's with, you know, just like today, you know, our collaboration and a little bit of education and sharing today with the Volpex organization, you know, passing along the information that there are solutions out there. You know, Canada's made some pretty aggressive moves, which, you know, continuing to support, you know, these policies to drive recycling programs and get rid of this linear model. Us as an industry, we've been working on harmonizing standards for recycling programs and just continuing to educate consumers and, you know, develop the supply chain so that we can handle more plastic waste. Whoops, excuse me. And so before I close up here, I'll give you a 30-second infomercial about us. You know, we're a recycling company that's servicing throughout North America. And really our objective for any one of you or any other companies out there is figure out how to make this plastic circularity simple, whether it's advanced recycling or mechanical recycling. We really want to make it simple, and we do everything to provide solutions for you, whether it's putting equipment in your facility or figuring out how to, you know, develop a return programs for your plastics. So one provider, many custom solutions out there for manufacturing and distribution operations. I think before we get into questions, you know, this is usually the number one question, and I'll go ahead and, you know, throw it out there to ask myself. You know, what does a recycling, or excuse me, a plastic recycling program cost? It's a fantastic question, and I never can give a direct answer, but I can tell you that, you know, if you as at your facilities have a large waste stream with plastics, generally the cost is nothing. So I'll give you an example. If you know, if you're a local big box retail and they start collecting film and they bale that film up, well, generally we're picking up the material for free or paying for that material when we pick it up. I think where plastic recycling programs, you know, become more challenging, or they go from, you know, a rebate back to you or a zero pickup, it's facilities that just really don't generate a lot of material. So those are the most challenging for us, where there's potentially a cost involved. So I'll give you an example. Say you're a distribution facility that generates, I don't know, 2,000-3,000 pounds of stretch film per year. Well, a typical truck loaded with stretch film is about 40,000 pounds. And that's the best way to optimize the loads. So when you think about recycling, it's all about a logistics game, and you've got material that's pennies per pound, and we've got to figure out how to optimize that to make sense. So very often a plastic recycling program may have a cost associated with it. If you have low volumes of material and perhaps you can't load out as much on a outbound truck out to your facility, so there's typically a cost associated with those type of programs. But more or less what we find over and over, if you're a large manufacturing facility, there's generally cost avoidance because you've avoided landfill costs, and, you know, generally we're actually buying the material from you. So, you know, all in all, it makes total sense to explore a plastic recycling program, and the solutions are out there. I think, you know, I think it's always good. I mean, you know, I've talked about 20 minutes here. I think it's always good to take some questions. Giselle, I don't know if we got any questions that came across the chat or anything that we could potentially address, or if there's one out there.
Don't have any questions in the chat yet. Please
I
feel
have
free.
one.
Oh,
Yeah.
perfect.
Go ahead.
Hi, Chad from GT. I got a question for you regarding the PCR stretch film. So, a variety of companies are coming out with this now, and I'm curious as to why you would want to use PCR stretch versus normal stretch when, as I'm aware, maybe you can clarify this, the PCR stretch, you cannot recycle it after one-time use, whereas the normal stretch, you can keep recycling it. So, why would you want to use that if you can't recycle it anymore? Could you explain a little bit more on that?
Yeah, so great question. So we recycle PCR film all the time. Whether it's post-consumer, post-industrial, if it has a PCR content. So the information you have, respectfully, is not correct. Because if it does have a PCR content, we've got no issue with that. Now, you can't infinitely recycle a plastic over and over mechanically, but because the recycling rates are so low today, that amount of PCR content or that material has been recycled once is not an issue for us. And if we did have a plastic that had a high, for example, it didn't have good properties because it had been recycled many times, that is a perfect candidate for this advanced recycling process where we can take the film, we can make new ethylene again, and then ethylene could go back to like a Sigma stretch to make new film again. So you've got multiple options to do that. So I hope that answers the question there.
Yeah, great. So you can reuse, keep recycling the PCR film.
Yep.
Awesome.
Yeah.
Okay.
Absolutely.
Thank you. That's a great question. Thank you, Chad. Does anyone else have any questions while we have the resident expert with us today? You do see Mark's contact information here on this presentation. This presentation's been recorded and it will be uploaded to the Bulpex portal for our members to view, of course, and you can share it within your organization. If anyone from your team wasn't present, you're more than welcome to have them view the presentation online. And of course, we can always count on the support of Sigma Stretch Film. And so if we need to get in touch with Mark for a specific question, we certainly have access to his insights and knowledge.
Giselle, thank you very much. And yeah, I highly encourage you, if there's a question that's out there, or, maybe it hits you next week, whichever, feel free to contact, myself or Jesse directly. And, if we don't know, we will get you the answer. But, when it comes to a lot of these plastic recyclability questions, we can, outright help you. So love to talk to you if you have a question later on. And thank you again, Giselle, for, coordinating this. And thank you for the opportunity to talk to the Bulpex organization.
Thank you so much, Mark. And Jesse, thank you to you and your team for providing the opportunity for us to have access to.
It's our pleasure, Giselle, and thanks again, Mark, for doing this. Again, we lean on you as much as we can when it comes to this type of conversation. So thanks again for being there. Thanks, Giselle.
Absolutely. Thank you, team.
Thanks, everyone. Have a great day.